All right, well, before we went to break, we wrapped up talking about isolation. We're not completely done talking about it yet, but now we're gonna talk about insulation. So this is the part that we're accustomed to, insulating ourselves from the energized conductors and equipment that are on the pole. This is making sure that everything that's within our minimum approach distance is insulated and insulated out beyond it, so that we can't take anything, we can't reach anything that's not insulated, and we can't reach anything with anything conductive that we have in our hand.
So are we considering the hose insulation?
Yes,
And isolation?
yes, but we're not gonna count on it. We're not gonna put a hose up there and lay on top of it, or have a, stand there again with our, purposely contacting the hose. The hose is for secondary protection, it's for accidental contact, so it's not gonna be for purposeful contact. The only thing we can purposely contact anything energized with is our rubber gloves. Everything else is gonna be up there for protection only. It still has the same insulation rating, it has value, we're not gonna count it as nothing. It is gonna move out, the minimum approach distance and allow us to get closer to things if we insulate them properly.
What about a MAC?
A MAC, now MACs are gonna be required to be tested also. So we have that also now, that they get tested annually, and we'll know that they're in good condition. The other part of it is inspection also. We still recommend, if you're gonna leave a MAC overnight, to not leave it in contact with anything at ground potential. To, put a blanket around the cross arm if it's gonna sit on the cross arm. Just because we have seen those things, if they're left overnight, go bad and fail.
We had them up for a month,
Yeah,
more than a month.
yeah. I've seen them in some spots up there forever. I saw, there was a hot arm that was in place for like 10 years in Columbus, and somehow the thing never tracked or anything. It was almost white by the time they took it down.
Oh, they did Easter Avenue, everything was, the risers and everything else, they were up there for a good month. and pulled
Yeah.
out every single Mac we have in it.
Yeah, but they were laying on the cross arms?
No, some of them were.
Some of them were.
Yeah. I would say most of them were, because they
Yeah.
on-armed everything else, so.
They're probably okay. I mean, if they're rated for 15 kV and it's energized at 7,200 volts, it's probably okay, but just as a good preventative measure, it's probably, and it's not so much, it's more to protect customers from having an outage. We just don't want to give that jumper a chance to fail by putting it, when we can isolate it, either by another blanket or hang it so that it's not in contact.
So with these being tested, these MACs, do you count on them as good as a hose being tested now too? As far as accident
It's the
contact?
same test, same theory, yeah. It's got a rating. The only thing is our Macs don't have our rubber cover-up has classes that like a class 1's good for 10,000 volts, class 2 is for 20,000, 3 is for 30,000. We don't have that with the Macs. Typically, there's like a 5 kV Mac or a 15 kV Mac.
We have 25s.
Do you have 25 kV Macs? So it's not the same insulation rating as the cover-up is. But if they're tested and if they're in good condition, yes, they should be okay for brush contact. Not purposeful contact, but yeah, for brush contact, they should be okay. Okay. So when we go to insulate, again, choosing a work position that puts us in a safe position. The safest position, meaning that the least amount we can come in contact with, is always the best. So in this case here, the guys are working, they're retying in this conductor. Let's say this first black line is far out as he can reach, and going this direction, that's as far out as he can reach. And the next black line would represent the minimum approach distance. So basically, where as far as he can reach, plus the minimum approach distance, that's how far cover-up would have to be. If he's got a tie wire in his hand, we've got to add that onto it also. If we've got one rolled up, a hand tie, I'm not gonna assume you unroll it, the whole 6 feet of it, and then point it out. It's rolled up and it's basically extends out of your hand 6, 8 inches, whatever. And that's your extended reach area. If it's a preform tie, that's a little different. Now we got, 12 to 14 inches hanging out of your hand. That's gonna extend your reach area and might get you to this center conductor here. So if you can set yourself up so that you're reaching out and you can't, this center conductor is more than your extended reach plus your minimum approach distance, we don't have to cover this center conductor then. So it's using our work position to determine how much cover up needs to go on. If we're gonna come up and work in between them here, because the next thing we're gonna do is do the next one, well then, yeah, we've gotta cover both of them. We're gonna have to have at least 2 hoses on both of them. Probably in both directions, because of our reach distance plus our minimum approach distance will take us out past the first hose. And you might be able to reach this conductor out here too. So it's a matter of looking where we're gonna set the truck up at, where we're gonna do the work from. Many times we try to set our truck up in a spot where we do all the work from one spot. It might be great for this phase here, but then once we move on to the center and field side phase, now we're stinger in between and we're trying to squeeze in between the neutral and the phase, and we're getting ourselves in pretty close proximity. If we've got a parking lot or a place to get the truck on the other side, it's worth it to move the truck, to pick up the stiff legs, move the truck around the other side, and get yourself in a position over here where we don't necessarily have to cover up this whole side to do that work. Because we're limiting the amount of phase exposure that we have to energize conductor exposure. We're only going to cover the things that are within our extended reach plus the minimum approach distance. Does that make sense? No. This is where we're taking the personal interpretation out of it and the personal comfort level out of it, where some guys might say, I'm not going to do anything. I'm not going to reach out that way. All I need is a hose here and a hose there, and that's all I need. No, we're going to take into account what's your worst case scenario. How far can you possibly reach with whatever conductive you have in your hand, and I want to see cover up beyond that. Now there's no way for you to make contact. And again, it's taking away any chance we have of accidental contact. Does that make sense? Okay, so we pretty much finished then well, we haven't totally finished, because now we get into the underground, which Eric brought up earlier, and this is the hard one. We bring a new cable in here. We're going to replace the cable. But we still got the transformer energized. So some guys have said, that's real nice, you must not have anything in there to be able to cover it that neatly, but we've got to be able to cover the elbows, which are considered energized, and the secondaries, which are energized. Because our goal is to be able to work on this cable here. And it's hard to do terminations, whether it's an elbow or an overhead termination with rubber gloves on. So how can we do that? We're going to have to get that out to a point where we can work on that cable, out away from that insulated cover up. We need to cover it first of all and insulate it, so that we can't make contact with anything energized. So this is one way you could do it. The other way you can do it is you can use a magnetic button on the side of the hood, go on both sides. I've seen the guys in Oconomowoc do this many times. They were changing elbows for quite a while when they were getting rid of all the old Elastimol elbows in the 24/9, and that was how they would go about. They would isolate the one cable, test and ground it on one end. They would put the magnetic buttons on there, and they would drape down a blanket over the top of the energized elbow that was in there and the bushing that was covered now with an insulated cap and the secondaries, bring the cable outside of it. You could even let the cover down to a point to kind of act as a barrier, because at some point, if you're going to be terminating this, we've also got that wire concentric neutral that we're flipping around. You got to be careful. It's a difficult one at best. About the best we can do in this case is to insulate it all so we can't make contact with it to the best of our ability. And then get it out as far as you can. You know, pull your excess out so that you're doing it outside of the cabinet as far as possible. And then we got our three-phase junction cabinet. And this is, I'm cheating already because there's only 6 cables in this one. There's an in and an out, and they're adding a third set of cables in here, so there's gonna be 9 when they're done, but they've covered the elbows here completely with blankets. And they're gonna bring the cables outside of the junction cabinet and let the lid down on them and terminate them outside of the cabinet then. That's about the best we can do. And it's probably not perfect, but underground's difficult. It puts us in very, as soon as you open up that transformer, you're in close enough, you're in reach distance. That's why gloves have to be on as soon as you open up the transformer, because you're already within reach distance. For Aaron, he's opening up a meter socket. We go back to the 120 volts, avoid touch. As soon as he opens up the meter socket, he can make contact with those. He has to be in rubber gloves before he opens it. Because once he's exposed to it, he can make contact. So here we are showing a guy who is insulated and isolated. He's got insulation on the phase that's closest to him. He's got a hood on there. He's got 2 hoses on there. Same with the center one, 2 hoses. He's got a hood on there. With the one that he's working on, he's got hoses on there. He's got a blanket closest to him to cover what he's uncovering and tying. This bi-unit arm, he's got insulated because again, it's fiberglass, but we're considering it a high resistant ground. It's still somewhat of a ground potential. The pole is ground potential. He's got a blanket wrapped around that. You can barely see in the corner of this picture, there's a rubber good down here on the neutral also. The one thing he's missing, he needs cover up on the pole down here because the bottom of the bucket is in pretty close proximity to that pole there. He also needs sleeves. Yeah. Georgia Power, these training slides, they're showing their guys how they can glove without, using cover up, they can glove without sleeves. They can't. Sleeves, we have to wear sleeves unless we can work from a position where we can't make contact beyond the cuff of the glove. Doesn't have anything to do with how many phases are up there or anything like that. In this case here, inadvertent movement, if it can take you out and take you past the cuff of the glove. In this position, he might be okay, but when he's turning that tie wire and it's energized, that's a little different story.
The way he's reaching too, all you do is slip.
Yes. I don't know how many times, you know, you got a bag from an Ampac connector or something, and you reach out and you slip on that piece of plastic in the bottom of the bucket and fall towards it, yeah. So there's, if you can work from a position where maybe you're working kind of a happy medium, you don't want to be so far that you can't control things. You want them close enough that you can keep good control, and you always want to keep both ends of the tie wire covered as you're moving it. And as you turn around, hold on to one end, cover the other end, continue turning it. Always keeping good control. But if you can work from that position, even if you slip forward, you're going to go under and down. You can't go up. So body position in that case would allow you to work without your sleeves on. That's about the only case. Our work rules say that you should wear sleeves. So unless you can't make contact with your upper arm, you have to have sleeves on.
Well, right there, that picture, I don't know, maybe he doesn't have enough boom, but to me, he should have been on the other side.
Yeah,
Get through and work it from the other side.
right.
I mean, it's just, you're limiting a lot of potential right there.
And it could be where the truck is set up. It's hard to say. Sometimes, you know, when you raise your lower boom, you're putting the boom into this phase over here.
Right.
If you go any further,
That's what I mean.
Can
I
we
don't
go
know
to the
what
other
boom you
side?
have Or what, but.
yeah. And that's, every situation is different. Where's the best place to set the truck up? And sometimes multiple settings for a bucket truck is good so that you have the best possible working position for each phase. Because if we try to do one to fit all, we might be compromising ourselves in some of the positions we got to get to. Some of them are going to be tighter than others when we could make it better by moving it. I had a meter tech in Manitowoc was telling me he had to place a rope CT for a power quality meter around the secondaries in a pad mount transformer. All he has is class 0 gloves. He doesn't have primary gloves or sleeves. There were so many 500s connected to this pad mount that he couldn't get the rope CTs around the secondaries there, so he needed to go over the top and take it around the bushing itself. He was going to be reaching past the cuffs of his rubber gloves, and he didn't feel comfortable with it, so he called the line crew out. They came out with their primary gloves and primary sleeves on and installed the rope CT, and that was exactly right. He didn't have the proper PPE to do the job, and in this case it was secondary voltage, and some guys will say, well, I don't wear sleeves unless I'm working on 3-phase. It doesn't matter what voltage you're working on. They were working on 120, 208 in this tub. Sleeves were appropriate because it was too hard to cover everything, and to reach past those spades there to put that rope CT on, the sleeves protected them in that case. So that was the appropriate thing to do. So general rules, we always want to stay insulated and isolated. Those two principles are going to keep us safe, even if we make a mistake and we touch something, or we have a glove fail. Or say we brush up against a line hose and the line hose is failing and we get a shock off of it. We won't get a shock if we are isolated from ground potentials and other potentials. We should always avoid body contact with anything energized. And we should always maintain minimum approach distance, beginning from your extended reach area plus anything that you have in your hand that's conductive. Important part of rubber gloving is having a tailgate before starting. The tailgate, we want to discuss the status of the equipment. Is it energized or not? If it is energized, what voltage level? Where does the minimum approach distance start at? What is the minimum approach distance for the voltage it's energized at? What PPE are we required to wear for this job? FR clothing, what level, safety glasses, hard hat, rubber gloves, rubber sleeves. How are we going to do the job? What's the work procedure? Talk that through during the tailgate so everybody knows what the process is going to be, and anybody can identify when we go off track or we're missing a step. And then what's the personal assignments? Who's responsible to do what? Do we need non-reclose or hotline tag? It depends on what you're doing. If you're going to go up and move out, untie a phase and move it out to a hot arm, yes, we need non-reclose or a hotline tag. If we're going up to put a hot tap on and close a cutout, no, we don't need a hotline tag for something like that. So it really depends on what we're doing. What additional hazards exist on the job site? It might be a work zone, construction site, might be a heavy traffic, it might be a school zone, things like that. And what, do we need to ground or barricade the truck? If you are working in a substation fence, you have to ground the truck. It has to be grounded to the station ground grid. If you are outside of a substation, you have the choice of either grounding the truck or barricading it, one or the other. Either way, we're going to treat the truck as if it's energized, because we can become a parallel path for current that's flowing through the truck if it becomes energized. So,
What if you're in the sub and it's de-energized?
what's that?
What if you're in the sub and it's completely de-energized with the truck?
Then you're fine.
Yeah.
Everything's de-energized, there's nothing energized in there, you're fine. And then any weather conditions which may affect the job. We do recommend that you avoid gloving in wet conditions. And we're talking normal maintenance construction work, that can be done today or it can be done tomorrow. It doesn't involve, we don't have any customers out. If there's customers out, you've got to do what you got to do. But we recommend, even if it looks like the storm's going to pass in 15 minutes, maybe it's a good idea to hang on and wait until the storm's done. The guys that work the 24/9 voltage know that even better, because when it's wet, even humid, the stuff bites you pretty good. Even 12 kV, I've seen the little blue sparks over your surface your gloves when it's raining good. It's just not a good idea. It's not that it's unsafe to do so, it's not a good idea, not worth taking the chance. So we recommend, it's not a requirement, but we recommend don't do it in wet weather. Always place a circuit on non-reclose or hotline tag. Don't trust a cutout upstream from you to be your one shot. That cutout might or might not be coordinated with the breaker. We may have had the wrong fuse installed in that in the past. Maybe you had a mutual aid crew there and they put a fuse in from their truck and it wasn't the type that coordinates with your breaker. And some systems are set up so that they want the breaker to trip first and come back on, so that when the squirrel gets up there and touches the line and he gets blown off the line, it trips the breaker and then the breaker comes back on and everybody's back in power and you guys don't have to come in to work. Some have it set up so that the fuse blows first and it doesn't affect the rest of the circuit. So it really depends on how it's set up. But there's no guarantee that fuse is going to be your first line of protection. So if you're out there working, you're making connections or untying and moving conductors, and put it on non-reclose or hotline tag, one or the other. Always wear the appropriate PPE. So we're going to rely on that section 4 in our safety manual, except for 407C. Everything else still applies. It is still what we're going to follow for our recommended PPE. We're going to identify all the ground potentials during this preparation time. What do we have to cover up there as far as the pole, the crossarm, anything that's at ground potential, and how are we going to cover it, and how much cover up do we need? And then what's energized up in our work area that we have to cover? How much do we, what are we going to cover it with? How much do we need? Determine those things ahead of time, because if the guy gets up there and starts covering things and he runs out of cover up on the truck, you're probably going to stop and just try to finish it with what you have, instead of having somebody stop by and drop off some more cover up, or going back to the shop and getting more cover up. So make sure you've got enough cover up, get it out, inspect it, make sure test dates are good on it, that they haven't expired, make sure they're in good condition. We can use gloves on our phase to neutral voltage, but only if we have no other phase potential that we can touch. Everything is insulated to the point that we can't touch anything else at another phase potential. So let's say Plymouth goes up to do mutual aid in Kiel on your 24/9 system, and all they have is class 2 gloves. They can work on that 24/9 system, but as they get to the first conductor, it has to be totally covered out to their extended reach area. Then they move to the next closest one, and they completely cover that to their extended reach area. And they go to the third one, they completely cover it to their extended reach area. Everything is completely covered. Now you can back out, cover your ground potentials. Once the ground potentials are covered, you can uncover what you need to work on and work on it. And you only have exposure to one phase now. That's the only way you can use a class 2 glove on a 24/9 system. Or it might be a class 1 glove on a 12 kV system. You gotta have either single phase or no other exposure possible because of insulation. Is everybody clear on that one? Okay. I'm gonna skip through some of this because we're running short on time. As far as care of your rubber gloves, if they get nasty, dirty, you can wash them with a mild soap solution. Store them in an approved bag. Don't keep them on the dashboard. It's not good to keep them in the sunlight for extended periods of time. Don't allow them to come in contact with any petroleum oil product that will start to degrade the rubber and cause it to break down and swell up. It's going to fail. We can use sleeves without, or we can use our gloves without sleeves. Again, based on our work position, as long as we can't make contact with our upper arms. Otherwise, we do have to wear sleeves with the rules say you should wear sleeves with your gloves. So it's only if you can't make contact with your upper arm, is the only time you can get away with not wearing sleeves. Doesn't matter how many phases or what the voltage is.
How come they never change that rule yet?
What would you like to see it be?
Always.
I think it should be always.
Always.
I mean, they want to avoid any
Yeah.
kind of
Yeah.
contact whatsoever, well,
Yep. That's a good point.
I mean, it's not that big of a deal to be wearing their sleeves also, I mean,
Yeah. I think the biggest reason is the same reason we have the ability to still wear a short sleeve shirt. It's because of the southern utilities that want to be able to wear the least amount possible because of the heat. I think that's the biggest reason they haven't changed it. Yeah. I think for us, there's very little times that we probably should be working with other sleeves. Testing your rubber gloves, you should air test them daily. I recommend a bench tester if you can get one. Look at, they're not real cheap, it's something you gotta budget for probably, but it does a nice job of doing your daily air test on your rubber gloves. It grabs it right by the beaded edge of the glove, and you can test everything above that beaded edge. If you roll them up, you're gonna miss the bottom 2 to 3 inches of that glove. And that's the part that's not protected typically. So I really do recommend those bench mounted testers. If you get one, make sure that you put a regulator on them, put a filter on them, because most of your air systems have got oil in them to protect to lube your air tools. So you don't want that oil to be getting inside your gloves, so make sure you put a filter on them to protect against that. This is the roll-up test. If you're out in the field and you think you might have pinched the glove, then by all means do your air test out in the field. Roll them up and you're gonna listen for air leaking. You're gonna stretch them, look between the fingers. If there's any spot that's suspicious, might have discoloration of the rubber because it got pinched, you stretch it, make sure there's no damage to it. On your sleeves, same thing. Wash them in a mild soap solution, mild dish soap solution. Don't roll them up and put them in your glove bag. They should be in a sleeve bag. If you roll them up and put them in your glove bag, they typically won't hold that round shape and they'll flatten out. When they flatten out, it stretches the rubber, and if they're left that way for an extended period of time, it can cause the rubber to fail on the rubber sleeves. So we shouldn't put them in our glove bag. As far as inspecting them, we should lay them out flat, kind of like our blankets, and roll them. Start with one side, roll them, and as you roll them, you're stretching the rubber, and anything cut or anything damaged to them will be exposed. Flip them over to the other side, switch to the other arm, do the same thing, both sides, turn them inside out and check the inside the same way. Make sure the equipment has all got test dates on it that are current, they're not expired. You should track your in-service dates so we know how long they can be used out in the field. If they've spent some time on the shelf, we want to know how much time you have to use those gloves. When it comes to testing your blankets, we do the same as the sleeves. You roll them on a flat surface. When you roll them, you're stretching the rubber and you're going to expose any cuts like we see here. There's a cut in that. You don't see it until it's rolled open. When we attach our blankets, don't use tape. The adhesive on the tape can trap contaminants down the road, which we could have tracking on the surface of that blanket then, cause them to fail. So you want to use clothespins, you want to use buttons or magnetic buttons, or Velcro straps, something that's not going to leave any type of residue on the surface of the blanket that can trap contaminants. This is another style of clamp, especially if we start looking at insulating the ground potentials. Getting around a pole and clamping it is difficult. This one will go around up to a 12-inch diameter pole, I believe. Might even be bigger than that, but you can clamp around large things with this clamp. When we store them, they should be wrapped tightly, or put in a tube so that they stay wrapped and they don't flatten out, or they should be hung or laid flat. We just don't want them flattening out so where they're stretching the rubber again, causing damage to the rubber. Your aerial device, we already talked a little bit about this. Make sure it's clean, make sure that it's tested, make sure you maintain it. Your line hose has an overlap on it. So it needs, when it's installed, that overlap needs to be in place. It's to prevent anything from sliding up inside of that hose and making contact. So if we're gonna insulate something and consider it insulated with the hose on there, it needs to be closed up so that we can't get anything into the side of that hose. Hose needs to be rated for the voltage that we're on. If we're coupling hoses together, the right size male and female ends have to go together so that we don't spread them apart and open up the bottom of the hose. Or we have to use the right size connector to hold them together. We can use a blanket over the top. The thing we don't want to do is the bottom picture where we open up one male end and put it over the top of another male end, and we leave the bottom open and exposed to contact now. Male end should never go to male end, right?
Right, Mitch?
Hopefully that goes without saying. All right, on your line hose, test dates are good. Roll it open. Again, we're stretching the rubber. It should expose any cuts that might be in there. If you find cuts that are more than a third of the depth of the rubber, cut them out. You can keep short sections of hose to use in areas where you can't fit a full piece of hose on. So we don't have to throw them away, but cut those sections out. When you store them, they should lay flat. The one that you see on the top here was hanging over the edge of a shelf, and it deformed the rubber over time, and now it won't close up because it got deformed. So it needs to be laying flat so that that doesn't get deformed. When we put our hoods on, they need to fit properly also. So if it's supposed to have two male ends or going inside the hood, then that's what we have. This one, it's got a female, it's got an end where a female end can go on one side and a male on the other. This one doesn't, and the female end's going in there, and it's spreading open the hood and allowing for something to come in from underneath and make contact. Pole guard can be useful in protecting ourselves from ground potentials. It can easily be wrapped around a cross arm or a pole. So having some short sections of pole guard can be handy as we try to isolate ourselves from ground potentials. You could put this around the pole, take one of those Klondike clamps and put it underneath just to keep it from sliding down the pole, and boom, you've got the pole covered that easily. So, when we go to insulate energized conductors from an aerial lift, we always want to start with the neutral and the secondary conductors, work our way up to the closest primary phase, work our way out to the furthest primary phase. When we're done with the work, we remove the cover up from the farthest one first, out to the closest primary phase, and then down to the neutral last. That should be the way we do it all the time. So here we got the neutral covered. And we get up there and we've got the bi-unit arm covered, we've got the pole covered, we've got the lines covered. Again, sleeves need to be on. So all the different things that are at ground potential up here, or other potentials. We got the arm, we got the pole, we've got the neutral below. You have to watch your hand lines also. Hand line comes up into your work area and you can make contact with it. We can't, even though like a poly hand line, say, is an insulating material, it doesn't have a dielectric rating and it isn't ever tested. So we consider it a high resistant ground. So if it's in your work area, you need to move it down out of the work area so that you gotta get something off the hand line, you'll have to drop down and get it off, and then come back up into your work area. Watch your winch lines also, same thing. We're almost at noon, so I'm speeding through some of this. We're gonna go out to the end on a summary. Can you speed read here? A lot of this is in your, it came right out of your gloving guidelines. There's a part in here on jumpers, and we talked about, these are some nice devices for insulating your jumpers, for hanging them and keeping them insulated. They just open up and hook around the jumper and the weight holds it closed. Always communicate well with your coworker when you're jumpering, or else use an insulated T-handle, but make sure the other guy knows when the jumper's coming hot. And when you make your taps, like we talked about before, make sure you try to use one hand when doing so, so that you don't put yourself in series with that tap when you're energizing the section of wire downstream. All right, summary. When we're working on energized equipment, it's important that we maintain focus. What's energized around us? What are we working on? What's our ground potentials? And keep it all covered. Make sure that nothing within our reach distance is uncovered except for what we're working on. Always stay isolated and insulated. Those two key principles are going to allow us to even suffer a worst case scenario of a glove failing and we still have no current flow through us and we have no accidental contact. Avoid body contact with anything energized. Don't have extended contact with, if we brush up against a line hose, we need to move our position a little bit so we don't do that again. That was a mistake. It's not intended for us to be able to come in contact with or lean against. So we need to try to move ourselves in a position where we're not going to be coming in contact with that line hose. Yeah, Eric?
You have to treat a fiberglass armor as the same as a one arm, correct?
Yeah, we're going to treat it the same way. Even though we know fiberglass is a natural insulating material, it doesn't have a dielectric rating, and because of being out in the sun and exposed to contaminants, we're not going to consider it an insulator. Always work from approved isolation devices such as a bucket truck or the backyard digger derrick or a rubber blanket or some 20 kV dielectric boots. It may be safer at sometimes to use hot sticks for certain things, so don't forget that. Sometimes it's, rather than grabbing onto it, we can use a shotgun, or rather than going up and putting the hot tap on with our hands, put it on with a shotgun. It might limit the amount of cover-up we have to put on. And always follow the APPA safety manual. Like I said, I don't want in any way for you to think that changing the one rule compromises, our following anything else in the safety manual. Everything else is still in effect, and we're going to follow it. Let's go through that quiz real quick. Got 5 minutes here, we'll be able to get through this. Make sure your name and utility name's at the top of it. Number 1, the gloving guidelines, or the procedure that establishes the minimum requirements for the gloving guidelines. So the answer is C. Number 2, employees who will need gloving retraining are identified at the following times. Choose 3 of the 4 here. The 3 of the 4 here are when periodic inspection. I come out and do a job site inspection. You're not following the gloving guidelines properly, we would do retraining then. We have an accident or an investigation and they come out and find out through the investigation that gloving guidelines are not being followed. We would do retraining then. We hire a new employee, comes in, maybe he's not familiar with our gloving guidelines. We would do retraining for that person. It would be new training actually for that person. Number 3, minimum approach distance definition. The closest distance an employee is permitted to approach an energized or grounded object. So it's A. Number 4, we have the 2 pictures. We have the 1 picture there. We have the energized conductor with the circle around it. That represents what? The minimum approach distance, yep. The circle that's around the alignment is his extended reach area. Yep. So that extended reach area, along with anything he has in his hand that's conductive, cannot enter that circle that's around the energized conductor that represents the minimum approach distance. If it can, he's violating the minimum approach distance rule. So gloves and sleeves have to be on before he can enter into that. Number 5, rubber gloves and rubber sleeves will be put on after entering the minimum approach distance. I kind of just answered that. It's false. It has to be put on before. Otherwise, it's encroachment, right? Number 6, rubber gloves are not required to be worn when insulating materials are installed on all energized lines, and equipment and work is not performed on energized equipment and conductors. So you got everything to your extended reach area plus anything conductive that you're going to be working with insulated. You're hanging tubs, you're making up secondaries on a bank. That can be done without rubber gloves. It's de-energized equipment. Number 7, isolate or isolating is defined as B, avoiding any contact that would provide a path to ground or a difference of potential. Number 8, isolating devices include insulated cover-up and a bucket truck, so C and D. A hot arm is keeping a wire that's energized from going to ground through the cross arm. It's not protecting you. A live line tool is a tool that we use to insulate ourselves from that energized line, but it's not so much an isolating device as it is a tool that we're using. Number 9, the cross arm, the pole, equipment, neutral conductors, guy wires, equipment cases, concentric neutrals, ground rods, secondary neutrals, and the earth itself represent what? Yeah, things that are at ground potential. Things we need to isolate ourselves from. Number 10, insulating yourself from energized potentials is accomplished with rubber gloves, rubber sleeves, and rubber insulating devices rated for the operating voltage of the equipment or conductors being worked on. Number 11, a crucial first step in any gloving procedure is conducting a tailgate. Any job, that's the crucial first step, is the planning process. Tailgate's got to be done. We got to determine, what we're working on, what's the work procedures, what's the minimum approach distance, how much cover-up do we need, what do we need to cover as far as insulated or energized conductors, what do we need to cover in regards to ground potentials and other potentials in our work area. Inspect the equipment. It's all part of your prep. Number 12, when rubber gloving, insulated sleeves are required to be used. We covered this a number of times. The answer is false, but it is required most of the time, unless you can work from a position where any inadvertent movement would not take you closer to that conductor so that you can make contact with your upper arm. Or we're hanging on to something like a tie wire that as we turn it, we could now make contact beyond the cuff of our glove. 13, when insulating energized conductors from an aerial lift, first insulate the secondary conductors and the neutrals. If necessary, next insulate the closest conductors, and then continue insulating out to the furthest conductors. When we take them off, we go in the opposite order. Furthest ones first, to the closest ones, and then the neutrals and secondaries. And the last one, always rubber glove from approved isolation devices, such as an aerial device, an insulated blanket on the ground, dielectric boots. You could be working from an insulated board, gloving board. That applies to everything unless you're below 5 kV. On a 4 kV system, you can still glove from the pole, from the ground potential. So we're not going to employ the isolation techniques if you have to glove 4 kV, but just always remember, you have no secondary protection of isolation when you're gloving 4 kV. You're not isolated from the pole. So if you make any accidental contact or if the gloves are bad, you have no backup protection there. So the isolation should always be used if we can, even on 4 kV systems. Just because we have that ability. If you can isolate, that's always our best choice. All right? We're at 12:02. I apologize for taking you over. Oh. You can pass those to the end if you want, or leave them on the table and I'll pick them up. I will send more copies to Plymouth.
Oh, someone needs that one?
I think we're good. Ryan, why don't you keep it? Oops.